Hello students, welcome back in this tutorial video. It's me, Dipendra Shrestha, science teacher of Daisyschool. Today I am here with the remaining part of the ray diagrams of convex lens from the class 10 science light lesson. In previous video we have discussed about the laws for ray diagram and one ray diagram of convex lens, and today we are going to complete the remaining ray diagrams of convex lens. Students, you have remembered or not? I had given one homework to you. Did you solve the ray diagram of convex lens? If not, look at here. Today we are going to complete the ray diagrams of convex lens. Okay? Last day or in previous video we have done the ray diagram of convex lens keeping the object beyond 2f. And today we are going to complete object at 2f, between f and 2f, at f, between f and o, and at infinity of convex lens. Similarly, a ray diagram of concave lens also today we discuss. Okay, so now second number, when object is kept at 2f. Okay, kept at 2f. So similarly we have to draw the convex lens f to f, how we have done in the previous video. Okay, first of all, by the help of compass or protractor, draw convex lens. Convex lens. After that, draw principal axis from its middle part. This is principal axis. This is the optical center, and draw the f and 2f. You know how to draw f and 2f from the optical center. 3 centimeter, 3 centimeter in your copy will be the better. Now here I am taking 5 centimeter, 5. So from this side also, 5, 5. 2f, f, 2f. You know, these are all 4 parts. O to f, f to 2f, O to f, f to 2f. All 4 parts must be equal. You know this because we have discussed already in the previous video. Now, according to the question, object at 2f. Okay, object at 2f. Now we have to keep the object at 2f. Object means arrow sign. Yeah, here we have to take arrow sign. We have to draw arrow sign at 2f position. It's a object. Let's say AB. This is AB is object. Yeah, AB is object keeping at the position of 2f. Now you know first rules or first laws of ray diagram for convex lens. Parallel light rays to the principal axis passes through the focus point. Another one, light rays that passes to the optical center passes without bending. But don't forget, in previous video we have discussed here position of object, position of image also. So at that time, I think you have observed at that time, when the object at 2f, at that time image also should be found at 2f position. Okay, that's why it is a little bit different. Your measurement must be correct, otherwise you will not get the position of image at the 2f. So look at here, parallel light rays to the principal axis passes through the focus point. Passes through the focus point. Okay, so parallel light rays to the principal axis passes through the focus point. Another one, light rays that which is incident on the optical center passes without bending. So here, from head of the object to optical center, When the ray of light incident on optical center, it passes without bending. So without bending position, okay? Okay, so light rays which is incident on the optical center passes without bending. This is the intersecting point. Okay, this is the intersecting point, and here the intersecting point image is formed. You know this because we have discussed in previous video. So this is the intersecting point, and here this position image is formed. So from this point we have to join the principal axis. Okay, principal axis. Don't forget it should be at the TUF position. We have done correct here. So this is the image, and you know object is here, image is in this side. That means object and image are on either side of the lens. At that time such type of image will be a real image. A real image is always inverted image. So arrow sign down, okay, arrow sign down. Here the arrow sign here is B, so we have to write here B dash. Here A, so we have to write here A dash. So A dash, B dash is image. Okay, this is image. Remember, this is image, and this one is object. Okay, object. Can you write the nature of image? Nature of image. Nature of image. Don't forget. Okay, when the object is kept at the TUF position, image also must form at TUF position of next side of the lens. Otherwise your diagram is wrong. You have to draw again. So here nature of image we are going to write. In previous video also we have discussed, if the object is in one side of the lens and image is in another side, then such type of image is real image. Real image. A real image is always inverted image. Yeah, inverted image. Now size. Look, this is the size of object and this is size of image. Size of object, size of image, both are equal. So same size of the image. Okay, or equal size of the image. Same size. It means equal of image to the object. That means size of object and size of image are equal. Similarly, at what position it formed? At TUF position. So when the object at TUF, image also formed at TUF. So at TUF. So we have completed. We have completed one ray diagram when the object is kept at TUF position. Similarly, we have to draw remaining one. Now, third one. Okay, third. Third, when object is kept in between YAF and TUF. It was homework. Don't forget. How you have done, compare with this. So now we are going to, I am going to use the same diagram. That's why, look at here. Okay, same diagram I'm going to use. So okay, so we are using the same diagram here. Now third ray diagram when the object is kept between YAF and TUF. Okay, YAF and TUF. So object between YAF and TUF. YAF is here, TUF is here. Between means you can keep nearly at the center. Between YAF and TUF. This is A, B object. Rules are very similar or same rule you can use here. So parallel light rays passes through the focus point. Rays of light that passes to the optical center pass without bending. So same two rules or two laws we are going to use. So ray of light parallel to principal axis. ray of light parallel to principal axis passes through the focus point. Okay, passes through the focus point. Passes through the focus point. First rule. And second rule, the ray of light which is incident on the optical center passes without bending. Okay, so ray of light which is incident at the optical center. Ray of light which is passes to the or incident to the optical center passes without bending, straightly it goes. So here you have to draw a little bit long line. Okay, so these two light rays are intersecting at this point. So it is the position where the image is formed. Okay, it is the position where the image is formed. So from this point we have to join the principal axis. Okay, principal axis. This is the image. Okay, this one is object and this is image. Object is one side of lens, image is another side of lens. So this type of image is real image. Real image is always inverted. So you have to draw arrow sign down. So at the B here is arrow head. So here B dash A, here A dash. So A dash B dash is image. Don't forget when the object is kept between F and 2F, then image is formed behind 2F. Behind the 2F of next side. Okay, next side. Don't forget this. So nature of image. So what type of image, real or virtual? Real image, because object and image are on either side. So real image. And another one, erect or inverted. Real image is always inverted image. Similarly, size. This is the size of object and this one is size of image. So size of image is bigger or smaller than that of the object? Surely it is bigger. Yeah, it is bigger. That's why we say magnified image. Okay, magnified image. So magnified image. Magnified image. And the position behind 2F. Okay, position behind 2F. So we have completed third one also. Similarly, next one, fourth ray diagram of convex lens. We are doing ray diagram of convex lens when the object is kept at F position. Okay, at F position. Focus point, principal focus point. We are going to do this ray diagram. So again, I'm going to use the same diagram. Okay, same diagram. So here, don't forget, same diagram I'm going to use. Okay, so we have to draw again lens F, 2F, principal axis up. Now we are keeping the object at F. So F, keep the object at F. Okay, AB is object. Okay, object. And rules, same rule. Yeah, parallel light rays passes through the focus point. Light rays that passes through the optical center passes without bending. Same rules we are going to use. So here, remember, parallel light rays to the principal axis. Parallel light rays to the principal axis passes through the focus point. Passes through the focus point. Okay, passes through the focus point. So first rule, Second rule, light rays that is incident on the optical center passes without bending. So same rule we are going to use here also. Okay, incident on the optical center passes without bending. Okay, passes without bending. So these two light rays are nearly parallel to each other. That's why they do not intersect on this board or on your copy. Okay, on this board or on your copy, when you extend these two light rays downward, they do not intersect at this board or on your copy. It is said that if we extend these two light rays continuously downward, then they will intersect at the infinity. Infinity means horizon, very far from us. Yeah, they intersect at infinity. So ray diagram this much. Now we have to draw we have to write the nature of image. So it is said that if we extend these two light rays, intersect very far from the lens or far from the object. That means object is in this side, image will be formed next side. That is also real image. A real image always inverted image. And when these two light rays is drawn downward or extend downward continuously, it will be very far from the principal axis. At that time, size of image will be very high. That's why we say highly magnified image. Okay, highly magnified image. At that time, highly magnified image will be formed. And when it forms, it forms at infinity. Okay, position of image not on our paper, not on the board. So it forms at infinity. Okay, infinity, symbol of infinity is this. Okay, in symbol of infinity, this, which means we cannot find on our paper. So this is fourth ray diagram. Now fifth one. Okay, fifth ray diagram. So fifth ray diagram, when the object is kept between F and O. Okay, when the object is kept in between F and O. O means optical center. Okay. So let's draw the diagram, ray diagram, by keeping the object in between F and O. Okay, F and O. So here is the F position, optical center, principal focus point. Okay, now position of object is in between F and O. In between F and O. So this AB is object. Again, rule same. Parallel light rays to the principal axis. Passes to the focus point. Okay. Similarly, light rays, which is incident on the optical center, passes without bending. So these two light rays, it seems extending outward. They are not parallel, extending outward. If we draw these two light rays continuously downward, they never intersect because they are extending outward. But if we draw these two light rays in the backward position, they may intersect. So let's try. So straight to this rays, let's draw the one line. This is dot line only. Okay, this is not real light rays. This is only virtual, you can say. Virtual, only we think. Yeah, if we extend it backward, then what happens? So at that time, if I have extended this light rays backward, similarly this light rays also Okay, these two light rays, if we extend these two light rays in backward position, then we find two light rays intersect at this point. Yeah, two light rays intersect at this point. So this is the place where the image is formed. Yeah, at this intersecting point, image is formed. So let's connect this intersecting point to the principal axis. Okay, intersecting point to principal axis. Okay, this is the image. Remember. Okay, yeah, this is image. And here is object, here is image. Both are same side of lens. If the both object and image are in the same side of the lens, then what type of image is that? That is the virtual image. And virtual image is always erect image. So erect image, arrow sign upward. Here also arrow sign up, here also arrow sign up, because it is virtual image. Yeah, it forms formed at the same side of the object. So A, B here, then we can write A dash, B dash here. So this is image, okay, image. Now let's write the nature of image, okay, nature of image. Let's write the nature of image. So what will be the nature of image? Real or virtual image? Both object and image are in the same side of a lens. So at that time it will be the virtual image, virtual image. Similarly, virtual image is always erected image, erected image. This is the size of object and this one is size of image. Okay, this is size of object, this is the size of image. Big or small? Big means magnified image. Okay, magnified image, magnified image. Similarly, position same side of object. Okay, same side of object, same side of object. This is the nature of image. And in that case, a small size of the object is magnified. That image will be the magnified. And this condition is used in simple microscope. Okay, in simple microscope we can see the small object into bigger. And this one is the case of simple microscope. Okay, by using the convex lens like a hand lens, palmist. Yeah, they use the hand lens to see the parts of flower. Yeah. This scientists use hand lens. This hand lens case is this case. When the object is kept between F and O, then image will be magnified and image will be erected also. Okay, this is very, very important. And next one, last case of the convex lens. Last case of the convex lens, when the object at infinity. When the object at infinity. Then when the object at infinity, okay? When object at infinity. When the object at infinity, let's draw the diagram of convex lens. O F to F to F. Okay. Now, when the object at infinity. Infinity means not at our paper, not on the board. It is very far from us. So object is very far from us. At that time, we cannot draw, we cannot keep the object on this figure, on this board. Only the light rays from that object we can capture. Yeah, we can capture. Like we can capture this image of very far distance object also. Yeah. So object is very far, but light rays from the far object also can be captured on the lens. So only the light rays from the far object we can show here, not object. Okay, not object. Only the light rays from object, far object. That's why we say parallel light rays. Okay, parallel light rays. This is one parallel light rays to the principal axis. This is another parallel light rays. The principal axis. Two parallel light rays that is coming from the object from the far distance. Yeah, when fall on the convex lens, then you know parallel light rays passes through the focus point. You know, parallel object light rays passes through the focus point. So, at the focus point, two light rays intersect. At the focus point, two light rays intersect, and this is the position of image. This is the position of image. So, very small image forms at that time. So, nature of image will be object is in this side but very far, but image is at the F. So, real image on either side of the lens. So, it is a real image. Similarly, real image is always inverted image. Yeah, and size very small, that means highly diminished. We see highly diminished, very small. Okay, highly diminished. And at what position it forms? At EF position it forms. So this is the ray diagram of convex lens while keeping the object at EF at infinity position. Okay, at infinity position. These are the ray diagram of convex lens. Usually convex lens are used in microscope, telescope, similarly camera. Yeah, in our human eye also it is convex lens. Yeah, like convex lens. Similarly to treat the far-sightedness. Yeah, far-sightedness also convex lens are used. So convex lens are used for the different purpose. Hand lens, that is also convex lens. In exam, it is very important. So practice at home. There is a 6 ray diagram I have drawn of convex lens. Practice at home. Practice is necessary. So all 6 ray diagram. Once again draw in your copy. Draw at home. Yeah, it will help for you. Yeah. So concave lens ray diagram we discuss in next video. There is magnification of lens, again power of lens, defect of vision, still remaining many parts of this lesson. So remaining part we discuss in the next video. For today, thank you.